Hello friends, and welcome to Webronaq. Picture this. A robot in your kitchen that makes your bed, cooks your breakfast, and does the laundry, all on its own, in a real unmodified home. That is not science fiction anymore. In April 2026, a company called Unix AI announced that its Panther robot had done exactly that, becoming what the company calls the first mass-produced humanoid robot deployed in real households. No lab, no staging, no script. Now here's the question that video raises for anyone in tech. What is actually happening inside that AI brain to make any of this possible? The answer starts with something surprisingly small. A token. In this video, we are going to build up the full picture, from the tiniest unit the AI reads, all the way to the billions of numbers that give it knowledge. Let us start with the basics. Alright, so the very first thing to understand is what a token is. A token is the basic unit a large language model uses to read and generate text. It is not a letter, and it is not always a full word. It sits somewhere in between. A fragment of a word, a short common word, or a piece of punctuation. In English, one token is roughly 4 characters long, or about 3/4 of a word. So a 100-word paragraph is closer to 133 tokens. Here is a concrete example. Take the word understanding. A model does not see that as one unit. It breaks it into 3 tokens: under, stand, and ing. Why not use individual letters? Because that makes sequences way too long and expensive to process. Why not whole words? Because you would need a vocabulary of hundreds of thousands of entries, and rare words or typos would completely break it. Subword tokens hit the sweet spot. Next, let us look at how tokens actually flow into and out of the model. Now let us talk about how tokens actually reach the model and come back out. There are 2 kinds. Input tokens are everything the model reads before it writes a single word back to you. That includes your question, any documents you attached, and the full history of the conversation so far. Output tokens are everything the model generates in reply. Here is the critical part. Both kinds share one fixed budget, called the context window. Think of it like a whiteboard, with a fixed amount of space. The more you write on the left side as input, the less room remains on the right side for the model to write back. A longer document you paste in means a shorter reply the model can produce, or earlier chat history gets pushed out to make room. This shared budget is why the size of that window matters so much in practice. And it is exactly what the big context window race in 2026 is all about. To understand why some models handle this better than others, we need to look at what gives a model its knowledge in the first place: its parameters. So what gives a model its knowledge in the first place? The answer is its parameters. A parameter is simply a number, a decimal value stored inside the model. Large language models contain billions, sometimes trillions of these numbers. Each one is a connection weight, a tiny dial that was adjusted during training to capture patterns in language. Think of it like a massive mixing board with billions of faders, all tuned at once. When training finishes, those values are locked. The model does not change its weights when you chat with it. What you type flows through billions of fixed multiplications, and the result is the next token the model generates. Everything the model knows, its grammar, its facts, its reasoning style, is encoded in those frozen numbers. That is what people mean when they say knowledge is baked in at training time. Up next, let us look at exactly how that baking process actually works. Alright, now let us see how those billions of weights actually get their values. It happens in stages. First comes pre-training, where the model reads trillions of tokens of text from books, websites, and code, adjusting its weights to predict the next token over and over. That gives it raw language ability. Then comes alignment. In RLHF, which stands for reinforcement learning from human feedback, human raters score the model's responses, and the model updates toward answers people prefer. A newer technique, RLVR, or reinforcement learning with verifiable rewards, skips human raters entirely for tasks like math and code, because you can check the answer automatically. Here is the interesting part. Epoch AI projects that the stock of high-quality public human text will be exhausted somewhere between 2026 and 2032, a challenge the industry calls the data wall. Labs are shifting to synthetic reasoning data to keep improving. DeepSeek R1 showed exactly this, using RLVR and synthetic chain-of-thought training to reach frontier reasoning capability. That shift in training strategy is what is now reshaping the entire context window race. Now here is where parameters and tokens come together in a very concrete way. As of June 2026, 13 frontier-hosted models ship context windows of 1 million tokens or more. The largest advertised window belongs to Meta's Llama 4 Scout at 10 million tokens. That sounds remarkable, and it is, but the number on the spec sheet is not the full story. The NVIDIA RULER benchmark, reported through Eternal in March 2026, found that models reliably use only 50 to 65% of their advertised window in practice. So a 1 million token model behaves more like a 500,000 to 650,000 token model when you actually measure recall. There is also a pattern called lost in the middle, where facts buried deep in a long prompt are retrieved far less reliably than facts near the start or end. Bigger context windows are genuinely useful, but the headline number is marketing. The real question is how much of that window the model can actually reason over. And that brings us all the way back to the robot in your kitchen, and just how much AI still needs to learn before it is ready for the physical world. So here is where everything comes full circle. The tokens, the parameters, the context window, the training pipeline, they are all remarkable pieces of a puzzle. But the robot in your kitchen is a reminder that language AI and physical world AI are still two very different mountains to climb. At CES 2026 in January, LG debuted its CLOID robot concept, and SwitchBot unveiled the Onero H1, both demonstrating household tasks like folding laundry and making breakfast. Then in April 2026, Webronaq's AI Panther became the first mass-produced humanoid to run tasks in real, unmodified homes. The progress is genuine, but experts point out that physical AI still needs its own version of the training data revolution. A robot that trips over a rug or fumbles a shirt is facing the same wall that LLMs faced before RLHF. The mental model to take away is this: parameters plus tokens are how AI reads and reasons about language. Getting AI to reliably act in the physical world is the next frontier, and it is still early. Thank you so much for watching. If this video helped you, subscribe to Webronaq for more clear, honest breakdowns of AI and computer science. See you in the next one.